First of all, let's talk about how a turbine flow meter works. A turbine flow meter is inserted in a pipe directly in the flow path. The mechanical part of the turbine flow meter has a turbine rotor placed in the path of a flowing stream. The only moving part of the turbine meter is the mechanical rotor. The rotational speed of the rotor depends upon the flow velocity. The rotor blades are usually made of stainless steel. As the rotor spins, the passage of each rotor blade past a pickup point will generate an electrical pulse. The electrical pulses are created in different ways, depending upon the rotor blades themselves and the pickup unit characteristics. In most turbine flow meters, magnets are fitted to the blades, and a magnetic pickup sensor is used to create the pulses. The higher the rate of flow, the faster the rotor turns, and the greater the number of pulses. The shape and the voltage level of the generated pulses depend entirely upon the type of pickup unit used. The electrical pickup sensing device could be a simple 2-wire passive magnetic pickup producing an AC type output. The electrical pickup sensing device could be a 3-wire active device, such as a Hall effect sensor, that produces cleaner and more uniform square wave pulses. As we said earlier, the turbine rotor will turn at a different speed depending upon the fluid flow velocity. Fluid velocity is a measurement of the distance a particle of a substance traveled per unit of time. Typical velocity units are feet per second or meters per second. Fluid velocity plays a very important role in the operation of a turbine flow meter, but in most applications, a turbine flow meter is used to measure volumetric flow rate. Volumetric flow rate indicates the volume of fluid that passes a point in a unit period of time. If you could count the number of gallons of liquid flowing past a certain point in 1 minute, you would be able to state the volumetric flow rate. Volumetric flow rate is expressed in units such as gallons per minute, or GPM, cubic meters per second, and cubic feet per second. Okay, so now we've reviewed fluid velocity and volumetric flow rate. Let's talk about how a turbine flow meter is used to measure volumetric flow rate. When you buy a turbine flow meter, it should arrive with a tag or a calibration certificate declaring its K factor. This K factor is unique to each and every turbine flow meter and is determined by the manufacturer. As we discussed earlier, the turbine flow meter will generate pulses, and the pulse rate depends upon the fluid velocity. The unique K factor declares the number of pulses that will be generated for every unit of product passing through it. K factor will be expressed in terms of the number of pulses produced, such as 150 pulses per gallon. Let's assume we are using a turbine flow meter to measure flow in gallons per minute, or GPM. This turbine flow meter has a K factor of 3 pulses per gallon. Recall that the unit for frequency measurement is hertz. 1 hertz is equal to 1 cycle per second. With that in mind, we say that the turbine flow meter produces a frequency of pulses per second, which we express as hertz. If we have a K factor of 3 pulses per gallon, the output frequency at a volumetric flow rate of 200 gallons per minute, or GPM, is 10 hertz, or 10 pulses per second. If you're wondering where we derived these values, we've included a very handy K-factor calculator for you to use. You can find the link to this K-factor calculator file in the video description. We can connect the turbine flow meter to a PLC frequency input card. The input frequency now represents the volumetric flow rate. If we are troubleshooting or performing loop calibration, we can use a calibrator with a variable frequency output to simulate the turbine flow meter. Here's an example of a turbine volumetric flow rate measurement loop. A 2-wire passive sensor pickup unit produces AC-like pulses, which are conditioned by an amplifier, before being sent to a high-speed counter PLC input module. Typical installation requires 10 pipe diameters upstream of straight pipe and 5 pipe diameters downstream. The turbine meter can only be used in clean, lubricating fluid, because suspended particles can easily damage the device. The turbine rotor must be positioned in the exact center of the flow, and laminar flow is critical, often requiring straightening vanes. Even though they are one of the most accurate volumetric flow meters in use today, they do have some downsides. The K-factor is not always consistent across the entire flow rate measurement range. Turbine flow meters are not accurate at very low flow rates. Viscosity is an issue, as thicker or thinner fluids can change the rotor speed and affect the meter's calibration. Keep in mind that the turbine flow meter K-factor was determined at the factory using a specific set of parameters. They are not recommended for steam. As with other mechanical devices, the rotor bearings wear out. In what industries are turbine flow meters used? Considering their popularity, a better question might be, in what industries are turbine flow meters not used? You will find turbine flow meters in oil and gas, including fracking, water and wastewater, chemical, power, food and beverage, aerospace, pharmaceutical, and pulp and paper. If you want to learn more, you might want to review 3 of our other videos: how flow meters work, what is sensor calibration and why is it important, and what are 2-wire and 4-wire transmitter output loops. You can find the links to these videos in the description. Okay, let's review. A turbine flow meter is inserted in a pipe directly in the flow path and has a turbine rotor placed in the path of a flowing stream. The higher the rate of flow, the faster the rotor turns, and the greater number of pulses generated by an electrical pickup. In most applications, a turbine flow meter is used to measure volumetric flow rate. Every turbine flow meter has a unique K-factor stating the number of pulses that will be generated for every unit of product passing through it. There are several important issues to consider when installing a turbine flow meter. Considering their popularity, there are very few industries where turbine flow meters are not used.